Hi, I'm Adrian Suwała, and welcome to the overview of the paper, Face Identity Aware Disentanglement in StyleGAN. This is a joint work with Bartosz Wójcik, Magdalena Proszewska, Jacek Tabor, Przemysław Spurek, and Marek Śmieja. Let me start by giving a quick background on the context of our work. When we want to extend the functionality and increase the control over generated images from a generative adversarial network, one approach is to use a conditioning variable. This, however, is often undesirable because it requires a potentially expensive retraining of a large generator. Instead, we can leverage a plugin model that operates on the latent space of a pre-trained generator and learns to disentangle its latent space into a number of controllable attributes. The motivation for our work is that although the existing plugin models can successfully modify the requested attributes, they also have a tendency to modify other features as well, such as person's identity. This can be seen when performing a sequence of edits on a single image. Our method extends plugin, which utilizes an invertible normalizing flow to disentangle the latent space of a pre-trained generator into two components, attributes and style variables. Attributes are disentangled features, with each attribute being modeled as a single-dimensional Gaussian mixture, and style variables serving as an entangled store of information required to reconstruct the images. We introduce plugin for faces, an extension of plugin into an identity-aware disentanglement method that explicitly disentangles attributes from a person's identity. It does so by encoding information about a person's identity into style variables. To do that, we introduce a contrastive identity loss that minimizes the distance between style components of images I and J that depict the same person. We train our method on a dataset of video frames with a variety of settings, expressions, and positions for a single person. We extend the dataset with additional images comprising only a single image per person to increase the diversity of attributes not seen in the video frames. The results of our method can be seen at first sight. It results in a significant increase in preservation of facial characteristics, as well as other details, such as background or person's clothing. We quantitatively evaluate our method using facial recognition models, such as ArcFace and Face Recognition Python package. To assess the preservation of identity, we use mean squared error between embeddings of original and edited images across all possible configurations. Moreover, we use peak signal to noise ratio and structural similarity, a raw image metrics, to assess background details preservation. Secondly, we assess the quality of disentanglement, using ranking correlation to measure the disturbance of non-edited attributes listed horizontally when performing a single selected modification listed vertically. We can see that plugin for faces outperforms the baselines on average and in 41 out of 56 possible cases. For binary attributes, we also report accuracy. In conclusion, we introduce an extension to a plugin method that forms an easy-to-use plugin to StyleGAN, which uses contrastive loss on video frames to explicitly learn to disentangle editable attributes from a person's identity. Our experiments and analyses demonstrate that plugin for faces is less invasive to other features and more focused on editing the desired features than the existing methods. Thank you for your interest in our work. We encourage you to check out the repository and scan the QR code to read the paper.